So good morning everyone and welcome to this lecture. This is lecture number 7 and we are dealing with the motion of center of mass. In the last lecture we had seen how do we find out the velocity and acceleration of center of mass. To find the velocity of center of mass we do the summation of MIVI and divided by the total mass. To find the acceleration of center of mass we do summation of MIAI and divided by the total mass m. Now, we had also seen that the summation of MIVI actually becomes the summation of momentum, and the momentum of the system can be written as summation of the individual momentums. And you can also write it as m into VCOM. Now, the external force acting on the system can be written as a total mass into ACOM, and then we can write it as d by dt of momentum of the system. Do we remember this, everyone? And we had seen that if the external force acting on a system of particles is 0, we can say that the momentum of the momentum of the system of the particles will remain constant. Here the individual momentum of the particle may change, but the final momentum of the system will be same as the initial momentum of the system. We understand this? We have seen the case where if the initial center of mass of the system of particles is at rest, then finally also it will remain at rest. We had seen the case where a bomb was exploding and we had to find out. Initially the bomb was at rest. If it explodes into two parts, we can find out the relation between the two momentums. Do we understand this? Yes or no? Do we remember this? Okay. Now let us try and do some cases here. One or two examples that might help us in understanding this concept. So let us write a question and I'll give you the question. Let us write a question here and I will try to make you understand. The question, let us say, goes like this. This is ground and here is a bomb. A bomb of mass m explodes into two particles. A bomb of mass m explodes into two particles in the ratio 1:2. A bomb explodes in the ratio 1:2. I hope we understand this 1:2 ratio. Yes or no? Okay. The heavier one is moving ahead. Oh, let me draw it correctly. The heavier one is moving like this with a velocity v. The heavier one moves along plus x-axis with a velocity v. Find the velocity of the lighter part. The bomb was initially at rest. It explodes into two parts. The heavier one is moving ahead along plus x with a velocity v. You have to find out the velocity of the lighter part. I'll give you 2 minutes to give me this answer. So how are we supposed to do this? The bomb explodes in the ratio 1:2. Mass of the bomb is also given. So I can find out the value of M1 and M2 in terms of M. How much will be M1? The lighter part. What will be the mass of the lighter part? Anyone?
1.
Yes. In terms of M, what will be the mass of the lighter part?
by 3.
M by 3. Correct. M by 3. And what will be the mass of the heavier part?
2m by 3.
2m by 3. Now, the bomb was at rest. So, initial momentum was how much? Initial momentum was how much?
0.
The final momentum should also be equal to 0. So, I have applied law of conservation of momentum, LOCM. Initial momentum, PI, is equal to final momentum, PF. The initial momentum is 0. The bomb was at rest. The final momentum should also be 0. So if I call the velocity of the lighter part as V dash, M by 3 into V dash is the momentum of the lighter part, plus the momentum of the heavier part is given as 2m by 3 multiplied by V. This V is given to you already. From here, you can find out the value of V dash. V dash will be coming as 2 times of V, and that is the answer that I was expecting. So we have found out this question with the concept of law of conservation of momentum. Do we see this? Do we understand what I have done here?
Yes, sir.
Okay, now I can add one more part in this question. I can add one more part in this question. The heavier particle, falls at a distance x. The heavier particle falls at a distance x from the bomb. The heavier particle falls at a distance x from the bomb. Find the position of the lighter particle. If the heavy part falls at x, find the position of lighter particle. We'll give you 2 minutes to give me the answer for this one. So how are we supposed to do this? We must understand that there is no external force acting on the body. There is no external force acting on the body. No external force, or the external force acting on this body is 0. Initially, the center of mass was at rest. The particle was at rest. Center of mass was at rest. So it will always remain at rest. It will not change its position. Initially, the bomb was at rest. The center of mass was at rest. Finally, also, it will remain at rest. That means the center of mass does not change its position. The center of mass does not change its position. Center of mass remains at the same position. Center of mass remains at the same position. There is no force acting on the body. Initially, the body was at rest. Initially, the system was at rest. Finally, also the system has to remain at rest. The center of mass will remain at rest. The center of mass will remain at the same position. I can call this position as the origin. So the initial center of mass of the system was at origin. O. The final center of mass of the system should also remain at the origin. It should not change. M by 3 into x dash m1 x1 plus heavier particle 2 by 3m into x must remain at the same position, and the same position I have called it as the origin. Solving this, you will get the value of x dash as 2 times x, and this is how we are supposed to solve this problem. Initially, the center of mass is at rest. Finally, the center of mass is also at rest. The center of mass does not go anywhere. It remains at its original position. I'll give you 2 minutes to note it down. If you have any doubt, beta, please ask. So this is the case where the bomb is exploding. I hope we have understood this case, yes or no? Okay, this was bomb exploding in one dimension. The bomb could have explode in 2 dimension as well. So I will give you that question also. Now if I let me make it this. Now the bomb could have exploded like this also. As you can imagine, these are your axes given. This is your plus x. This one is your minus x. This one is your plus y. And this one is your minus y. Now the bomb is here. The bomb of mass m is here. Now it explodes into three segments. One is this segment which moves like this with velocity v. Another is the green segment which moves with a velocity v by 2. The mass of this segment, let us say, is m by 3. The mass of this segment, again, let us say m by 3. The mass could have been different, doesn't matter. So, two segments have flown like this. Can you tell me how will the third segment go? Where would the third segment go? By common sense and by applying a bit of physics, where would the third segment? The mass of the third segment is definitely m by 3. Where will it go? Let me make this velocity as v, not v by 2. Yes. Where will the third segment go? Can you tell me along which axis will it go or in which quadrant will it go? Anyone, any idea? Third segment.
Z-axis, sir.
Yes?
Z-axis.
Z-axis. No, it's not going to go on Z-axis. Trust me on that. It's not going to go on the Z-axis. It will remain here in
X-axis.
Yes, beta?
Minus x-axis.
Minus x-axis. No, it will not go in minus x-axis. It will go like this. Somewhere in the third quadrant it will go. So with what velocity v dash will it go? So I can solve this question in two ways. Either I can solve it vectorally because now they are going in different directions, or I can do it scalarly. What I can do If I want to solve it vectorly, I can do it in this way. I can apply law of conservation of linear momentum, law of conservation of momentum. Initial momentum vectorly should be equal to final momentum vectorly. Bomb was at rest, so initial momentum of the bomb was 0. The final momentum of the bomb should also be 0. The final momentum of the bomb. So the final momentum of bomb would have m by 3 into v dash vectorly plus m by 3 into vi. This is the momentum of the red ball. This one. This is the momentum of this one. This is the momentum of this one. I have written it vectorly. I hope you are able to understand this. Plus m by 3 into v along j axis. This is the momentum of this. I have written it in the vector form. M by 3, M by 3, M by 3 will get cancelled. And I can get the value of V dash. V dash vector will be equal to minus Vi minus Vj. That means it will go. That means it will go in the third quadrant like this. I can find out the value of this V dash. The value of this V dash will be V square plus V square ka root. That means it is root 2V. And the angle that it makes with the x-axis would be 45° V by V. This is one way of doing it by doing it with vectors. Instead of doing it by vectors, we can have done it in a different way. How could I have done this? So I will just do it on the left hand side. I could have broken this. I could have broken this velocity into two components. One of the component will be known as Vx and the other component will be known as Vy. So I break it into x and y components, and then I can apply law of conservation of momentum, LOCM, law of conservation of momentum along x-axis. In x-axis, my dear friends, the initial So in x-axis, my dear friends, the initial momentum is 0. The final momentum should also be 0. The final momentum should also be 0. So this 0 should be equal to m by 3 into Vx plus m by 3 into V. This is the momentum of the body which is going along x-axis. So I will get the value of Vx as minus V by 3. Minus means if this is going in the plus x, this one is going in the minus x. So from there, I can get the velocity ka x component. Similarly, I can apply the law of conservation of momentum along y-axis. One is going up, so the other one has to go down. So I will get the answer as negative. Initial momentum is 0. The final momentum should also be 0. The final momentum of one of the body is m by 3 into Vy. I have not written it as negative. I already get it as negative. Plus m by 3 into V. This m by 3 into V is the momentum of the green body. This m by 3 into V was the momentum of the pink body. From here, bacho, we can see that you will get automatically Vy as minus V, not V by 3. Vy as minus 3 Vx is minus 3, Vy is minus 3, and that is Vx is minus V, Vy is minus V. So you do it in the left hand way or you do it by the right hand way. Both the answers are going to come similar. Everyone has understood this? I'll give you 2 minutes to note this down. So then let's move forward. The other type of question that can come here is the bullet fired from a gun. Type questions where you fire a bullet from a gun. Now, when you fire a bullet from a gun, normally the velocity of the bullet is given. If the velocity of the bullet is given, we can find out the velocity of the gun. That is known as the recoil velocity of the gun. Recoil velocity of the gun. So this is how the question can be. This is one way in which the question can be asked. Capital M is the mass of the gun with the man. The man will be holding the gun. Small m will be the mass of the bullet. Capital V will be the velocity of the gun. Sometimes it is also known as the recoil velocity. So they may ask you what is the recoil velocity. This recoil velocity of the gun is with respect to ground. Sometimes they may give you the velocity of bullet, a small v, with respect to ground. Remember, it's a very important term that this velocity is with respect to ground. Now, when a man is about to fire the gun, the initial momentum of the system is 0. When he fires the gun, he will get a push in the backward direction because bullet moves with a large momentum in the forward direction. He gets a recoil, that is known as a recoil. Initial momentum of the system is 0. The final momentum of the system should be 0. From there, I can find out the velocity, the recoil velocity of the bullet, the recoil velocity of the gun, or the recoil velocity of the man. And the recoil velocity of the man would be equal to, you will get a minus sign here. Capital V will be equal to minus m by minus small m by capital M into V. The direction of this recoil velocity is opposite to that of V. Do we understand this? Do we understand this? Now, this is first case where V is given as the velocity of the bullet with respect to the ground. Sometimes this V is given as muzzle velocity. Sometimes instead of giving you this V, they give you the muzzle velocity. Now what is muzzle velocity? Is the velocity of bullet with respect to gun. So if the velocity of bullet with respect to gun, the muzzle velocity is given to you, please listen to me very carefully and write it in your language. If the muzzle velocity is given to you, 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 which is the velocity of bullet with respect to gun, bullet with respect to gun, muzzle velocity, bullet with respect to gun, muzzle velocity, blue with respect to the bullet with respect to gun. In that case, the velocity, the recoil velocity of the man becomes m into v upon small m plus capital M. Muzzle velocity and the velocity of bullet with respect to ground, both are different. In first case, the bullet velocity is given with respect to ground. In second case, the bullet ki velocity is given in terms of with respect to the gun muzzle velocity. the formulae become different. Give you 2 minutes to note this down. Let me know once you are done. The next case that we are going to do is similar to this bullet and gun. But now the bullet and gun are somewhat different. There is a man. This is a man. The man is the bullet. And this is a platform. The platform is the gun. So what happens here is man is walking with respect to the platform. This W is the velocity of man with respect to the platform P, which is same as the muzzle velocity, because muzzle velocity is the velocity of gun bullet with respect to gun. Man is the bullet. Man is moving. This capital V is the velocity of platform with respect to ground. So you can understand this as the recoil velocity. When the man walks on the platform goes back. Do we understand this? Yes or no?
Sir.
If initially the platform is at rest and the man starts to walk, ding, 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 platform will go here. Initial momentum is 0. The final momentum has to be 0. Do we understand this?
Sir.
So basically what is given to you normally is the velocity of man with respect to the platform, and they ask you what is the velocity of platform with respect to ground. This question is exactly same as bullet and gun. So you can find out, or you can write the value of 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 V, capital V, in terms of W, or let me not write it as W, I can write it as small v. W may confuse you. Small v. Small m is the mass of the man. Capital M is the mass of the platform which is recoiling. I can write capital V. Can anyone tell me the formula, since I have told you so much that it is same case? What will be the value of capital V? No one knows it? It will be M into V upon M plus capital M. This is exactly same as the case of bullet leaving the gun, and V is the muzzle velocity of the bullet. Muzzle velocity, velocity of bullet with respect to gun, velocity of man with respect to the platform. Do we understand this?
Sir.
Okay. Now sometimes one more question is asked here. They give you the length of the platform. They give you the length of the platform as L. So man starts from one end and he goes to the other end. Man starts from one end and he goes to the other end. Man starts from one end and he goes to the other end. Then they ask you how much distance the platform has moved. How much distance the platform has moved. How much distance the platform has moved. If I call the distance that the platform has moved as L dash, L is the distance which the man has moved with respect to the platform. L dash is the distance that the platform moves with respect to ground. Can anyone tell me what will be the value of L dash? Just applying common sense and not physics. Everything is right in front of your eyes. Can anyone tell me what will be the value of L dash? No one can tell me. It will be equal to M into L. upon small m plus capital M. So please note these two formulae as formula for man walking on a platform. I'll give you 2 minutes. Once you are done, please let me know. Well, the next case that you can understand is again a case where here the initial momentum is not zero. You have a block kept at rest like this, and a bullet comes from one side. It hits the block and it rests inside the block. So what will happen? The block and the bullet will start to move forward. Do we understand this? Here the initial momentum is not zero because the bullet is moving. So this is somewhat different from the previous case. Here the initial system is not at rest. But what happens is, as you can see, the formula of the mass and the mass and the bullet is coming on similar lines, mv upon m plus m. Do we see this? So I can put them in the same category because they are the coming as same. So the bullet get inside the mass and the mass and the bullet moves together. Everything is there. We have to find out the velocity of this system after bullet has hit. So it will come as mv upon m plus v. The initial kinetic energy is half small m into v square. The final kinetic energy is half capital M plus small m into capital V square. So it will come as this one. Remember this formula. The final by initial kinetic energy is m upon m plus m, which is less than 1. That means some energy is lost. Some kinetic energy is lost. We are going to see this case again in something known as perfectly inelastic collision. So we'll see that perfectly inelastic collision right now. We can take it as an example of law of conservation of momentum. Everyone understands this? I'll give you 2 minutes to note
Sir.
this. Then this is the same case. You just have to draw the diagram. This is the same case, but now I have hung this body from a string. So now the bullet will come. The bullet will strike. It will remain inside the block, and this block and the bullet will move up. Do we understand this? Same case. Do we understand this? It is the same case. Don't have to write everything that is there in this. You don't have to write the heading. You just draw the case. Same case. The bullet and the block, they move with this velocity, yes or no? Then they rise up to a height h. So you just have to apply law of conservation of mechanical energy. Lock में total energy at the lowest point, point A, is equal to total energy at the point B. At the point A, the gravitational potential energy is 0. Do we understand this? They have written it wrongly because the mass and the bullet both move together. So when you apply lock में up till what height will it move? So yes. So you can apply the law of conservation of energy from there at the initial point. What is the energy? Half m plus m into that v square that we have got. At the highest point, the energy is m plus m into g into h. You can cancel this m. You will get h as v square by 2g. So up till what height will the system rise? V square by 2g. Do we understand this? So up till the velocity wala point, the question is similar. They will just ask you how high will it rise. You can just apply law of conservation of mechanical energy, and h will be equal to v square by 2g. Do we understand this? Okay. So this is all that we need to do in this particular topic. But this law of conservation of momentum is not going to end very soon. It is again going to come in a big way from the next class. So I hope that you have understood what we have done till this class. Yes or no?
Sir.
We'll continue our discussion. This is a long chapter. It will take some time for us to complete it in the next chapter. Remember, if any class you miss, in the next class you will not understand anything. If you don't come to the class without studying what we have done in the previous class, you will not understand anything in the next class. So please be very careful. From now onwards, do not miss a single class and do not come to the class without studying, else everything goes down the drain from there on. Take your leaves and we will see you tomorrow at same time. I hope. God bless all of you. Bye bye.
Bye bye.
Thank you, sir.
Bye beta.